2 of assignment 5. So after you've loaded all your shape files under your table of contents, you can go back to the question, and you see that question 2 is asking is that using the data provided from in the Kenya folder, buffer the bank agent points shapefile to create a file showing the service areas and kilometers from any bank agent. So basically what the question is asking is that all these little points that are called the banking agents, they actually wants a 7-kilometer buffer around each point. So you guys know the application of buffering in the town planning context. You can use buffering particularly maybe for BRT stops, if you want to maybe determine the portion of the area that qualify for a certain density. Use buffering also for environmental sensitive areas planning. Let's say if you want to buffer rivers or certain ecological zones. So now I'm going to take you through the buffering process. So when you want to buffer, you can come to your ARC2 box, open it, then okay, mine is already uploaded, but obviously yours will just appear like this. So when you come to ARC2 box, come to analysis tools, click on the plus sign to drop it down, and then come down to where it says proximity. So once that's done, you can click on actually buffer. So the actual quite a few analysis tools under buffering. You can actually create a normal buffer. There's actually another called a multi-ring buffer when you maybe want to create buffers, let's say 5-kilometer buffers, 10-kilometer buffers, 15-kilometer buffers, but in the form of an actual ring. So we can actually focus on the first one, which is buffer, just a normal buffer. Then as you can see, it's going to call for input feature. So as from previous assignments, for input feature, remember we want to buffer our banking agents, so click on that. Just waiting for that to load. I think because there's quite a few agents, obviously it will take a bit of time. Then output feature classes, where you want to actually save the actual buffers. So if you have already folder connected, or automatically save it within your connected folder. So you can name this banking agents. So make sure you put an underscore for space, banking agents underscore 7-kilometer buffer. You can click save, and then under your linear unit, so the linear unit actually, this is where you actually stipulate the actual size of the buffer or the radius of the buffer. So make sure to change this into kilometers, because remember they want it in kilometers, and then click 7. Okay, then you can come down, you can ignore those. Then you have your method, you can change it, you can leave it at planner, but for interest sake you actually have geodesic. So you use geodesic when you have multiple coordinate systems. So basically if you're working on a data frame that dissects multiple coordinate systems, so basically maybe if you're working from a world perspective, that's when you use the geodesic. But because you're working in a particular coordinate system, you can just use planner. Then the dissolve type, so we have none, we have all, we have list. So now dissolve type is actually when maybe buffers, when they actually clash, so instead of them having separate borders, you can actually make it dissolve. So you can click on all, and then you can click on OK. Then just wait for it to process. Okay guys, as you can see, the buffers have actually worked. If I zoom in, you can see that all the banking agents have been buffered by a 7-kilometer buffer radius. You see on your far left under your table of contents, the new shape has actually been added, the banking agents. Remember, under one of those options we chose dissolve, and you can see the effects of a dissolved buffer. So instead of creating multiple ring buffers under each banking agent and overlapping, it actually combines those buffers that intersect each other. So it just makes it come out a bit neater. So now with that done, we can actually move on to part 3 of the assignment, which deals with the use of standard query language.